Previously we saw that the objects that we were tracking on screen were stationary and the camera had to be moved, calibrated, to be at the appropriate distance so that the minimum match score was met and the object will be seen, will be visible to the camera. Hence, machine vision would be functional. So, reversing that principle and keeping the camera stationary but moving the object, we can determine a few things, such as the velocity of the object. We can also determine the pixel coordinate system in X and Y, and we'll be able to now track moving objects using this camera. And with the graphical user interface, the coding that has been written in the block diagram, data can be recorded and written to a file. So let's go ahead and attempt to record the data and see if we can verify these results that are measured by the software, sensed by the vision of the camera, with respect to what is actually happening in the real world. So we'll have to set up the rolling object and start the program and time it over a specified distance. The object is 400 millimeters in the Z direction away from the camera and is going to be traveling 400 millimeters in the X direction, Y direction being vertical. So let's go ahead and set up this test. The test is completed at the object taking 3.97 seconds to travel 400 millimeters, and the data has been recorded and written to file. It's also interesting to note that the minimum match score is average at 500. This is to make it easier to detect the rolling object without losing track of it, and also to make the results a little bit more accurate. As you can see, we've tried to use a white background and reduce the possibility of noise, but even so, there have been occasional instances where the vision has detected background noise which it has interpreted to be the object of interest. So this will all show in the recorded data, but more importantly, the tracking of the object will show the parameters that we're interested in, that we can use empirical analysis to compare with the real world scenario.